Hello everyone, welcome to the AI Club. My name is Uddesh Soman, and today we are going to have a look at RNN. So we have already covered recursive neural network in our theory lectures. Now we are going to have a look at the tutorial part. So I've added some description of RNN, the types of RNN we are going to see. In this tutorial, we are going to see these three types of RNN or the types of RNN problem. One to many. So having a single input and then we predict multiple outputs. Many to one, we have multiple inputs and we predict a single output, or many to many. And many to many also has various kinds like same number of items or more number of items. So first we will see these examples for numerical sequences, and after that we'll move to a use case in which we will predict the next word of a sentence using RNN. So I've added some description and link for theory part. If anyone wants to check, you can check out. I'll share the code file. It will be available. Uh, okay, so here all our general libraries that we import. In this particular problem, we'll mostly require the LSTm. We can import it from Keras layers. Then bidirectional, we will also have a look at bidirectional LSTMs. So for that, we'll need bidirectional, and the rest are uh, the rest are not so important. We can have a look at them later. Our general function for plotting the history of our training instances. So we'll have a plot of our score for training and validation set. So it simply takes the history object uh, Keras model, Keras sequential, takes the history and just makes plot using the history data. Here we are taking MAE, mean absolute error, for plotting. So we'll have mean absolute error. The blue one will be training. The blue one will represent training records for each epoch, and the orange one will go with testing.
So all these libraries will be available on this Colab Pro, no?
Yeah, all are available. Even if you run into an error that certain library is not available, you can just run the command pip install and then that name of library.
Okay.
So these ones are already available on Google Colab. So you do not have to separately install using pip command. So starting with the first one to one. So for one to one, we'll have a single input, and that will give us a single output. Single input means a single sequence. So consider if we have a time series. In this example, this particular example, here we have sales records over the years. So this goes into some sort of sequence. So what we'll do is we'll take a single sequence. Single input not does not mean a single entity, but a single sequence. So we'll take couple of records and then we'll predict the next record. So like in case we have records for these few months, like 1960 January, February, March, April. If we take these four records, then we'll make a prediction for 1960 May. That's what we'll do. So here we have this function to generate our sequences. We will pass our sequence and number of steps. This is our sequence, and number of steps means what would be the size of input sequence you'll pass to the LSTM. So n steps mean number of sequence means we'll try with five sequence, which means we'll pass a sequence of five entities and then predict the sixth entity, like that. We just have two lists for we will have two lists. Using this list we our x and y, we'll generate our x and y data sets. And then we'll just go with a for loop to append our sequences to these lists. This for and ending index, so I plus n steps. So if we have, let's say, a sequence of 5 entries. So we'll start with ith index, whatever the index be, and then plus 5. So we'll get our end index.
What is there in
Uh,
X and Y? What is there in X
ex-
and what is there in Y?
these are sets, na data sets. We'll need a input set and a output set, right? Or target set. We generally create x and y sets, na, like x is our input data,
Yeah, yeah.
multiple columns. In this
No,
case,
no. So
x is a
here
list
in
of
this
our
case,
sequences.
we have now timestamp and the cells volume, right? So X is timestamp and Y is volume or what?
X is a sequence of timestamps, like first 5 months of that data. So if we put n steps is equals to 5, so whatever the data of first 5 months be, it will be in x, and the data of sixth month, because we are predicting the next entry in the sequence, right?
Oh, okay.
So whatever be the sixth entry, that will go into y, like that. So
Okay.
each sequence, like first to fifth, then target is sixth, then second to sixth, then target is seventh, like that. It will generate data for x and y. It will
So
append those.
X is
Yeah,
also a two-dimensional array and Y is X is the training and Y is the prediction. वैसा है क्या?
yeah.
Okay. ठीक.
X is input training set, y is output. So far we haven't split them into training and testing. These are just this is just our data. We are making sequence and output, just that. Okay. We have this if condition to break in case we exceed the length. We cannot exceed beyond the uh, available sequence, right? So in case we exceed beyond that, so there is a break statement. If ending index exceeds the length of sequence, then we break. Otherwise, we go with this. We For x, the x data, we take from ith index to the end index. Ith index till end index. We take those entries, we put that into sequence x, and sequence y, just the end index. Here the end index, this notation, this notation is actually Python list slicing. So we'll get ith index is included, end index is not included in that sequence. So if we are saying first to sixth, if end index is sixth, then first to sixth index not included, means first to fifth, and then the sixth index ends up in this sequence. Okay, we'll store them in our list x and y, and then we are just converting them into arrays, because they are list of lists. So we are converting them into array of lists. That's the code. We import our data set. It's available on this link. I copied that link and put that path into read CSV command of pandas. And here we have our df. We take the values, all these values, we take them out of this data set. They get stored in this values array, and as type float. We convert that into as float 32. So it becomes an array of float 32 kind. Float 32 means decimal type values. Next, we specify the window size or number of number of entries we want to keep in our sequence. For each sequence, number of entries we want to keep. That ends up in n steps. We just call our previous function and get our x and y. These are our data sets separated into input attributes and target attribute. We reshape them. Reshape here for LSTm. We have to reshape in a manner that number of samples, it's a 3D vector. It becomes a 3D vector x. So number of samples for number of timestamps. Number of timestamps. So as many number, if we have, let's say, uh, five five timestamps, then number of samples, then a sequence of 5 entries with a single feature, because here we only have one column, a single feature. We can have multiple features as well. We'll see that in another example. So we reshape it according to our data. Once X is reshaped, we call our train test split n test. So what we are doing is, again, using the slicing, we all entries from zeroth index, first zeroth index to n test not included, that goes in X, means X train, and up to and beyond that, and nth test and beyond that, that goes in testing set. Same goes with Y. So we are simply splitting it into training and testing sets. Once we have that, we can see the shape. So number of entries, length of sequence, and number of features in each sequence. So here we only had a single feature. So 1. The length we specified was 15. So 15, and number of entries in each. Okay. The data preparation and all is clear so far, right? So I'll proceed with explaining the model.
सोमन, ये इसमें ट्रेनिंग और जो टेस्टिंग का, या ट्रेनिंग और टेस्टिंग का देख रहे हैं ना, तो
हाँ,
उसमें पूरे चारों इसमें टेस्ट ही दिख रहा है, तो वो इज इट ओके?
नहीं सर, हमने एक इंडेक्स क्रिएट किया है, 12th नंबर, 12
हाँ
नंबर का इंडेक्स क्रिएट किया है।
हाँ
तो ये -n डाला है।
हाँ
-n मीन्स पीछे से 12th। सो लास्ट की जो हमारी, क्योंकि सीक्वेंस बन रहा है, हम अब रैंडम ट्रेन टेस्ट स्प्लिट लेंगे तो वो शफल कर देगा वैल्यूज को। शफलिंग हम नहीं कर सकते ना टाइम सीरीज में, वो सीक्वेंस
हम्म,
मेंटेन रखना है। सो
हम्म,
जो लास्ट से 12 वैल्यूज हैं, फर्स्ट इंडेक्स से लास्ट 12th वैल्यू, वहां तक हमने स्लाइस करके एक्स में डाल दिया। ठीक है।
हम्म,
और वो स्टोर होगा किसमें? एक्स ट्रेन में। ये असाइनमेंट ऑपरेटर लगाया ना, तो वो स्टोर हो जाएगा एक्स ट्रेन में।
हम्म।
Yeah, so
वो
what I understand, Uddesh, is here you're
या
manually doing. Usually we used to call that scikit-learn function, right?
या
Which
ट्रेन
used to
टेस्ट
kind
स्प्लिट,
of shuffle and then do.
बट इट शफल्स द डेटा ना,
Yeah,
दैट
correct. So here you don't want shuffling, that's why you're
we
doing
do
it
not want
manually.
shuffle. Yeah,
Okay.
we have manually done that. We just we just separated the last 12 rows of the data. We put them in this testing set. We created this testing set, right? So we are assigning it. This is simultaneous assignment. You can consider it as 4 separate assignments. Python has this feature of simultaneous assignment. You can assign multiple values in a single line. That's why. So just see the order. First is our X train. So whatever comes after this slice goes into X train. Then whatever comes after this slice goes into X test. Same goes for Y. All to all up till n test goes into Y train, and n test and beyond, whatever n test till the end, it goes into Y test. That's it. Any more problem here?
No, it's fine.
Okay. So I'm continuing with the model. So we'll just make our model. So same thing we do with same thing we have done so far with Keras in ANN and CNN. We declare a sequential model, and in that we add an LSTm layer. So LSTm is we do not have to do anything. LSTm is already available. We have imported it earlier. Add LSTm, number of neurons you want to keep, or number of units you want to keep in LSTM, activation, activation function, you can select from any of the available activation function. We are going with the ReLU because also this one is kind of a regression problem here. Okay, because we are taking certain numbers and predicting a number and a continuous number. So this is a kind of a regression problem. And LSTM actually handles both kind of problems, regression as well as classification. So depending on our target or depending on our purpose, we can select, we can design it either in regression manner or classification manner. Kernel initializer. So we just selected normal distribution for that, and input shape. So whatever be the size of our sequences we are providing. So here we are providing a sequence of 5 entries. So that size 5 and 1 because we only have a single feature. This part.
Technically, is there a limit on the n steps?
No,
Here,
you can
we can.
select it. It all depends on the user. You can select as many entries in a sequence.
Okay.
The only limit is the size of sequence. You cannot go beyond that, right?
Yeah. So if I were to compare this rather than a numerical kind of thing, if it was sentences probably, then I can
Yeah.
have an entire paragraph fed into this.
Yeah, you can have it. I'll show an example, right? Just
Okay.
I prepared an example with paragraph, but it didn't work so well because the data, because of insufficient data, it didn't learn so well. It was giving some weird output, so I dropped that one. Just going with a simple example, but that is something we can do. But
Okay.
we'll just need sufficient data to train our model to get
Okay.
the good results.
Okay.
Okay. So again, simple. We just add our dense layer. We add 100 neurons in the first dense layer, or since we are doing regression, so a single neuron in out last dense layer, and then just compile the model with optimizer, Adam law, optimizer Adam loss MSE. So loss function here we have selected is mean squared error. Mean squared error. We can also go with mean absolute error, and matrices is mean absolute error. We can pick either of those values. This is actually a much better plot of. Okay, why isn't my scroll working? Yeah,
Yeah, Udesh, one
this is
thing on
yeah.
this number of cells in LSTM, and just can you just help us, means we have taken 100, 150, 50, so means we have some idea on this dense layers of CNN, and those things, no?
We
And
can
also
pick
ANN
we
also.
can we can pick any number of units, any number of neurons. It's entirely up to us. If a
Yeah.
problem is more complicated, it needs a denser or a more deeper network, we can add more layers. We can make it denser with higher number of neurons. Or if a problem is simple, like this one here is a simple problem. Even I think 100 neurons are too much. I just I just use those. But even with 50, the result would be more or less the same.
So in this we have taken 100 cells of LSTM,
Yeah.
100 neurons of dense layer, and
Hmm.
in finally only, since we have to predict only one, so we have taken only one neuron for the final layer,
Yeah.
right?
We have already seen an ANN, the regression problem.
Yeah.
Regression problem only needs single neuron in dense layer. It uses the ReLU function. That's why.
Okay, okay, okay. ठीक है. Okay. Thanks.
So a visual, this one is a better visualization tool for models. The plot model function. You can import it and then just go with your model, whatever your model is, just call it and show shapes equals to true. Model.png, you can name it if you want to save it, otherwise no need. My cursor isn't working.
So this plot actually doesn't show the CT layer, is it?
Which layer?
Means like there are three outputs, right, for LSTM. Means one input, and then you have the previous context and a separate output.
Yeah,
It
no, it doesn't.
it doesn't. Okay.
It just, and then we just fit our model. We already have our model. We have our data. We fit it with our training and testing sets. We provide validation data, so it ends up in the history, and we summarize diagnostic. I've already explained the function above, so we get this kind of plot. Just a second, please.
Just one question. So now the
Yeah.
model is ready. So can
Mhm.
we just for means model is ready, validation is also good. So can we take
Mhm.
a sample? How means suppose if I have data for maybe 1960, then
Yeah,
how it will
I made a
predict?
prediction. I made an example of prediction here.
Okay, okay, ठीक है, yeah.
Okay, so once we have trained it, prediction. So just a simple function, this model dot evaluate takes in x test y test and will provide us our MSE and MAE, mean squared error and mean absolute error. We'll print those values. If we square root them, we'll receive. If we square root the mean squared error, we'll get root mean squared error. We make a prediction, so we just we make a single list of entries like this. We convert into array and then reshape it the same way we did for our x tests, x data. So here we have single sample n steps because 5 entries and a single feature. So we just create this test example. We predict it, and after predicting, we print its value. So according to the data we had there, the output should have been 14,577, and our output is 16,328. So it's within the limits of mean absolute error. So if it is acceptable, we can go ahead with the model. If we want a model that makes better prediction, we can make a denser model or deeper model.
Okay, and because this is the prediction, right? So by
Yeah,
any chance, can we also have the timestamp data with this?
stem data. Actually, I
Because
haven't
that is
created here.
also year wise now. So if I have to give the final output, then that will also,
Hmm.
because I know it is maybe it can be, I think
You
it can
can
be in
you'll have to you'll have to manually code for that. You
yeah, yeah.
That
So
is
maybe in
possible, but
Excel
you'll
sheet
have
we can do that. In Excel sheet also maybe just delta timestamp or something we can.
no. Yeah, you can do it in Excel sheet. You can do it here as well. Just have to pick that data frame we had and add it here. Like here we have taken out a certain row, right? We created a row from the
Hmm.
data. Instead of manually creating the row, we can just go with indices from the data set. So using those indices, we'll have our timestamps as well, like the year. We can print the timestamps from the timestamps. We can print the timestamps concerning these data. Okay, it will go something like this. We'll have to generate an index. So we'll need start index, end index will be start plus n steps. Start plus n steps, we'll get our starting and ending index, and we can just slice our data set. So as array, the whatever name of our data set, and we can simply provide start and end index, and we'll get the result.
Okay. Yeah. ठीक.
Like that's what you wanted, right? You wanted timestamp here along
Yeah,
with
because
the
for the sake of completeness, now it is. Yeah.
we can do that. Means that is not the part of means that's not the part of model or its prediction. That is something that is something we want to generate for ourselves.
Right.
That is the idea we want to generate for ourselves to visualize that.
Right.
We'll have to do work on it. We can try a here I've tried a deeper model with more layers, and also because the LSTM gives one dimensional input output, whatever the output is, it becomes single dimensional as it comes out of LSTM for dense layers. So if we want to add more LSTM layers, here I have used multiple LSTM layers. So if you want to use more LSTM layers, then we'll have to use this function. Return sequences is equals to true. By default, it is false. We'll have to declare it as true. Otherwise, it will raise an error. So whatever the LSTM network has learned, whatever LSTM network has learned, it is not flattened into data. It is forwarded as a sequence. The whole sequence that we provided during the input, during the first input, the provided as input to the first layer, that ends up as a sequence to the sequence output to the next layer. So we can add multiple LSTM layers. We just have to keep this in mind. And also don't keep it as true while connecting with dense layer. Otherwise, it will again raise an error. So this one is an example of multiple LSTM layers with the same data set. So I'll show you the model. It looks something like this. First LSTM layer, first input layer, then 3 LSTM layers, and then dense layer. So if we fit the model, it had errors at first. Now we can see with epochs, error has reduced. Still not, means the training and testing sets are still not close to each other. Comparatively, they are. Like if we were to compare at this point, it was something around, means for the first epoch, it was something around 10,000 and the testing error was 16,000. Now it has reduced to some 2 to 3,000, means difference of 1,000. We'll check that in evaluation. Okay. So for the final model, we receive once we evaluate our testing sets, we get mean squared error and mean absolute error. Uh, this. So we have this high value of mean squared error. It's because we haven't scaled down our inputs. Our inputs are our inputs aren't scaled down. Usually we scale down using min max scaler or standard normal scaler. So whatever MSE we reduce is MSE or mean absolute error we receive is actually low. Here, since these values are absolute numbers, so it's high. And mean absolute error of 3,146. Again, the same values are used as input. And once we predict, we receive this value, but we can see it's way away from the actual value. The previous model was better. So we can try multiple models, or better to use a hyperparameter optimization. The hyperparameter optimization goes the similar way, like it did for CNN and ANN. So instead of trying multiple models like this, one can prefer that hyperparameter optimization. Then this one is the example for multi-feature one-to-one. So previously we have seen single feature, like we had a sequence, one-dimensional sequence. Now we have multiple sequences. It's still one-to-one, but we have multiple features in our data set. So we create two lists, X1 and X2. these sequences are just generated similarly, x plus 1 times 2, x plus 1 times 3 in range 25. So 0 to 24 and just plus 1 and into 2. So we receive these two sequences and their output is multiplication of these two values, x1 and x2. So we just use the zip x1, x2. So it actually picks values from picks up index-wise values from x1 and x2, multiplies them, just puts them in these variables x1 and x2, multiplies them, and whatever the result of multiplication, it ends up in y. Y is also a list. So here we have the first two rows are x1 and x2. We have 2, 4, 6, 8, 10, 12. And then for x2, we have 3, 6, 9, 12, 15, 18. And their product in this y. Simple, nothing difficult. Then we just use numpy column stack. So it actually generates those, generate the column. So 2 and 3, 4 and 6, 6 and 9, 8 and 12. So this kind of column we receive. Again, we reshape them. So 25 feature, we have 25 features. Since here instead of using a sequence, we are just going with single entry. This single entry. So 1, because we once the length of our sequence, it's 1. And 2, because number of features. So as many number of features that comes in the last input, the third dimension. And we just convert y label into array, nothing more required. Because our machine, that Keras sequential receives array as input. Array or pandas data frame, it cannot receive list. So we have to convert it into array first. Then we declare our model, the same model I've shown earlier. And we take model summary. You can also plot that image that I've shown earlier. We then fit our model, and once fitted, we go with our test inputs. We just took any input, random input. So answer should be product of these two values, that is 4,400. And when we run our model, means when we predict using this test input, we receive 3,825, quite close to this value. We can improve our model also. This summary of our model. So moving on. We are going with many to one. So earlier we had a single sequence. Now we can use multiple sequences and then predict a number. So we just generate an array x plus 1 in range 45. We reshape it. So 15, length 3, and a single that single feature. But instead of a sequence, here we have 3 separate sequences of single units. 1, 2, and 3, and 4, 5, and 6. We generate a list. So for x in x dot sum. So whatever be the sum of these 3 values, that is our y data. These are generated values. Means I didn't have the data, so I used the example where sequences were generated. We can do the same for more complicated sequences as well. We have our y data now. Again, convert it into array. We forward them into our model. We fit our model, and on testing, output should be 153. We receive 147. So that's what it has learned from our data. Now coming to bidirectional LSTM. So we have, I think we have also covered bidirectional LSTM in our theory sessions. So to make a bidirectional LSTM, all we have to do is just add a bidirectional layer And inside the bidirectional layer, we add our LSTm layer. That's it. Everything else goes same. We fit our model, we train our model, and when we predict, we can see the actual output was 153. We received 151.34. So it is better than the previous one. Again, we can do multi-feature many to one. So here we have multiple features. We created two separate arrays, and then we just stack them together using Numpy column stack. So we receive these two columns. We reshape our data. So 15 samples, 13 that three inputs and two features in each input. That is 3 by 2 matrix, right? So we pass that. The same is actually our input shape also. So when we pass input shape into our LSTM layer, we just copy these values. Our Y data set. So these are a couple of numbers. Go with these. We define our sequential model. We train it, and then we should receive our result. Instead of creating a separate validation data, we have just used the validation split. So whatever data we pass as input, 20% of that data ends up as validation set, and 80% is used for training. Check our MSC. And we can do a test input. We provide a test input. Answer should be 75. We receive 72. Again, we can do bidirectional LSTM for that. So all we need to do is add this bidirectional layer, and inside the bidirectional layer, our LSTM layer. We fit our model and we predict. So actually 75, we received 71. The previous one was better. Also, we can improve our model in the later stages. So next we have target list type problem. So let me just check the output of this one. So our target is actually list of values. We can have many inputs, and then output should be a single list. Output should be a list of those list of multiple outputs. So since it's a list of multiple outputs, it's become a single output. It could be a many to many problem or a many to one problem. That depends on our consideration. But since it's the coding wise, it will remain same. We generate our input set. So two columns, x1 and x2, we generate them. We stack them, create our training data. Y list. So for x and x new item list, we append these values. Whatever is in second row and 0th column, add 3. Whatever is in second row, first column, add 5. And we append that value to y. So that becomes our input data. Target data. Again, we define our model. Everything remains same. Input shape is according to the training set or X set. So we just put our input shape accordingly. The model remains same. We fit our model and we get the output. Yeah. So the prediction, we passed this array. The prediction should have been 29 and 45. We received 29.19 and 48.67. Good enough. Again, we can do, we go with the same bidirectional LSTM. It all remains same. Output is 29 and 48 again. So not much improvement, but we can try multiple models in that way. Any doubts so far?
No questions. Just that I was expecting some sentence kind of thing. That's all.
Yeah, I have example of sentences as well. I have this another example prepared.
Okay.
I'll show you that one. I'm going with sequences first because it would be easier to understand each kind of RNN, and
Oh,
then
okay.
once we have understood, I can use that analogy to explain it for word sequences.
Okay. Okay. Sure.
That's why I'm starting with this. So next up is one to many. In one to many, so we take single input and we are making multiple outputs. So here we take a single input, whatever the single input be, we are predicting the next two values as multiple output. We create those data sets, convert them into array and reshape them appropriately. That goes into model and we receive our output. So we our test input was 10 and the output should be 11 and 12, next two values, right? So we received 11.03 and 11.97. It's a regression problem, so we'll receive continuous data, but we'll have to see how close they are to actual value. We can go with bidirectional LSTm as well, and also we can go with example of multiple features. It all remains same as I explained before. And the last one, many to many. So we create separate list. We create our Y set. Also, in this one, we have to reshape our Y set according to the task. So we are reshaping it as 3 by 1. And then here we have to actually add this repeat vector because comparing three separate in order to compare three separate vectors, we have to go with repeat vector. It may not be required, but I have used here. That repeat vector actually, instead of here we haven't added the return sequences, right? So that repeat vector recreates those sequences. So if you, in case you do not want to use that return sequences command, we can have repeat vector. So using repeat vector, we can actually change the size of sequence during in the between two layers. We can change the size of sequence. You might want to train your first LSTM layer on a sequence of 5 entries, and then the next layer on sequence of 3 entries. So in order to do that, we can here just remove that return sequences and just add repeat vector. You cannot exceed the size of original provided input sequence. So if we have provided a sequence of 5, we cannot say repeat vector 6. We'll have to go with 5 or less. That is simple. And then the rest all remains same. Time distributed, if that is actually useful dealing with time series data. So it actually keeps that time record as well. Not exclusively necessary though. We can do our model without it as well. The output would remain same. We fit the model, we summarize the diagnostics, looking good, and then we make our predictions. So we provide this input, test input 300, 305, and 310, and the return output should have been 315, 320, and 325. The values we received are quite close to the actual value, so it's a good model. Okay, so I went with the numerical sequences. Now to see the actual use in sentences, I'll show you another example. Here we have it. We just take all those libraries and data path. This is a text file actually. So I stored that text file is in my Google Drive. I'll provide that text file as well while sharing the code. We convert it into a data set. So we create column names, and while reading data, we provide these column names. And since it is a text file, we use this delimiter. So wherever it is a tab, this is tab separated data set. So where backslash t means tab, separation using tab. So wherever we find a tab, we break it and consider it as next column or next entry. After going through this, we receive our input or the data. So we have total 5,351 samples of 3 words: word 1, word 2, word 3. What we'll do is we'll have word 1 and word 2. We'll use word 1 and word 2 as input, and we'll predict the word 3. Whatever the word 3 is, we'll predict it. So this is the check of frequency of words. So we have called the values count on input that are data set. So for the first word, we have only these few words. Second word, we have so many. And we also keep a count of unique words. So whatever number of unique words we will receive, so we are just keeping a count.